Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everybody, I'm Aisya. I was a mechanical engineering student at Gajah Mada University and Ehime University, Japan. So in today's video, I want to give you one example how to present your experiment in front of your supervisor or professor. So actually, I presented this experiment when I was in Japan in front of all my friends, my supervisor and professor in the class, but I try to represent to you because I want to give you one example how to present the experiment and how to open our presentation, give some conclusion, and I hope you can get benefits or some knowledge about mechanical engineering, especially in XRD, ceramic materials, and materials field. So, okay, let's start the presentation. I hope you can enjoy this. Okay. Bismillahirrahmanirrahim. Good afternoon, everybody. The Honorable Yamamuro Saiki Sensei, thank you for this opportunity. I'm Aisya. I will convey my experiment during here about synthesis of the silicon carbides using microwave heating with mixed and unmixed silicon powders. So this presentation includes the short of introduction, experimental method, results and discussion, and the last is conclusion. Nowadays, microwave heating is often used to synthesize the materials because energy efficiency, sustainability, economic viability have become increasingly important in the materials manufacturing sector. And microwave heating methods helps to achieve those criteria by providing rapid processing. And the other advantages are it can create high temperatures within a very short time, exceeding 1000 degrees Celsius, often affording high yield and high purity products. Faster, simpler, and more cost-effective process. The other side, it also provides the added attraction to access new and potentially metastable materials and understand the interaction of solids with electromagnetic fields. In my experiment, is IC or silicon carbide has been a representative example of microwave synthesis. Is IC is functional materials many application because of its appealing wear and corrosion resistant at high temperature, high thermal conductivity, and good thermal shock behavior. Owing to its superior mechanical strength and mechanical stability, that is why SiC is functional materials in refractory, aerospace, and electronic industries. To attain SiC pass by microwave heating, mixtures of silicon oxide and carbon powders are used as the reactant substances. In this experiment, we make SiC from silicon oxide plus carbon following to this reaction. So here, the solid powders of silicon oxide reacted by carbon powders become silicon oxide and carbon monoxide gas respectively. After that, the gas of silicon oxide gain the carbon molecule and reacted become solid state of silicon carbide, and the reduction result is gas of carbon monoxide. So for experimental method, first of all, we prepare the plain powder. We use silicon oxide powder with particle size is 4 micrometer and the graphite powder with particle size of about 75 up to 106 micrometer. We made 3 samples of mixing powder with atomic ratio of silicon oxide and graphite is 1 by 1. We calculated it and the result is 0.1665 gram of carbon and 0.8335 of silicon oxide. Then it's mixed manually by hand for 5 minutes. And one sample is a mixing of 1 gram silicon oxide only. Second, we fill into an aluminum crucible. The crucible is surrounded by refractory material or refractory ceramic fibers. and we make a layer circuit sandwich. The bottom is 1 gram of graphite, the middle is 1 gram of mixing or unmixing of silicon oxide, and the top is 1 gram of graphite. Hereinafter, the crucible was placed in a hollow in a block of heat-resistant brick. We closed the top part with aluminum lid and a piece of heat-resistant brick to gain good heat protection and insulation. Then it was irradiated by microwave with 6,000 watts. All 3 mixing samples were treated at different times, 5 minutes, 10 minutes, and 15 minutes. The one sample of unmixing silicon oxide, just 10 minutes treated. After the heating was completed, the crucible was air-cooled to room temperature. And we removed the product from the crucible and crushed it into fine powder using mortar and pestle. Lastly, the samples was characterized by XRD and we examined it. So we will say or we talk about the result. The result show us increasing the duration time of heating up to 15 minutes is increasing the growth of SiC or silicon carbide with a cubic crystal structure or beta SiC. At 5-minute heating, the peak of beta SiC and graphite is really weak. After 10 minutes and 15 minutes heating, the peak intensity of silicon showed a sharp of enhancement. We can see here the 10-minute pattern and the 15-minute pattern. There is no big difference. So we can say if the reaction of silicon oxide and carbon to make silicon carbide formation is finished in 10-minute heating. In the first sample of mixing silicon oxide with graphite that heated at 15 minutes, there is a decrease in the peak of beta SiC. So for this result, we show that is because there was unmixing powder when we shake it. Or the more we shake it manually by hand, so we cannot get the constant mixing. And we can see here, when I compare the silicon oxide plus graphite and silicon oxide powders only that heated in the same duration time, 10 minutes, the peak of silicon oxide only is really weak. There is a small peak of crystal light because when we heated the silicon oxide powders, the quartz of silicon oxide can be changed to crystal light. And if we heated it more, then it becomes amorphous. There is no peak of beta SiC because only the surface of silicon oxide that react. This result show us if the mixing process is really important. If we mix it, the contact surface will increasing directly proportional with the increasing of reaction rate. We can see also there is a peak that I signed it with X. So when I enlarge in this spot, there is a region of stacking faults along 33.74 up to 35.22. This region is referred to Tateyama et al. In 1998 about quantitative analysis of stacking faults of SiC. At 2 theta, 88.14, there is a peak of alpha SiC with the polytype of 2H SiC because the relative intensity of 2H SiC is 1%. As we can see in this picture, the path of beta SiC is cubic crystal with an ABC stacking sequences, but there is any error in the regular sequence of layers that occur here. You can see in this picture, and we name it stacking fault. So the peak of alpha SiC appears. In this picture of silicon oxide that has been heated, the powder was consolidated into a solid chunk with diameter is about 40.5 millimeter and the thickness is about 6.5 millimeter. So the last is conclusion. So the conclusion, microwave heating method is a good method to synthesize the materials, for example, silicon carbides or SiC, with its simplicity and its speed in raising the temperature. Increasing apparent time of heating is increasing the growth of beta SiC. And in this experiment, we got the maximum intensity of beta SiC at 15 minutes heating, but at 10 minutes, we already gained the C sub of enhancement. Mixing process is very important to gain the SiC. As you can see before, when we heating and mixing silicon oxide, there is no peak of beta SiC. But in the 3 mixing samples of silicon oxide plus graphite, we gain the SiC. Okay. Last, I really thank you for your attention. So in this closing presentation, I write my friend's name, all of my friends that helped me to finish this experiment. I write their name in kanji. So this is Kimura Shota and Takasugi Ryo and then Imagawa Yuki. So I really thank you to Yuki, Takasugi, and Kimura, to my professor Yamamuro Saiki Sensei, and all of my friends at Department of Material and Science Engineering, Ehime University. So, okay, guys, just it. I hope you can enjoy this presentation and get some knowledge about how to present your experiments and ceramic powders, especially silicon oxide, silicon carbide, and graphite, and then XRD. That's all for me. Thank you. Bye-bye.